My name is Leo Francis, URK24CO 2005. This is Machine Learning Laboratory experiment number 5. So as you can see, I am importing the pandas, NumPy, and many packages like model selection, neural network, pre-processing SPM metrics from Scalar. And first, I load the dataset by Toyota.csv and I clear it by removing columns with more than 30% of missing values and filling the missing values like for categorical data I'll be filling the values with mode, which is the most frequent value. And for the numerical data, I'll be filling with the median. Then I convert the category variables into numerical format using encoding. And as you can see here, next is to define targets, regression, and classification. I define two types of target variables, regression and classification. Regression means the predicting the actual price, and classification means converting the price into binary. So if it's above median, it converts into one, and if it's below median, converts into zero. So this allows me to imply both regression and classification models. And the third one is the train test split. And here I split the data set into training and testing sets to evaluate performance. Then I apply the standard scaling where the mean becomes zero and the standard deviation becomes one. So after that, you can see that we have the MLP, where the neural network models. So I use the multi-layer perceptron models like multi-layer perceptron classifier and multi-layer perceptron regressor. So multi-layer perceptron classifier predicts the class labels, and the multi-layer perceptron regressor it produces the continuous values. And after that, you can see that I evaluate performance using the accuracy for classification and the MSC and R square score for regression. And the next is the hyperparameter tuning. I improve the neural network by tuning parameters like increasing the hidden layers and adjusting the learning rate and adding the momentum. This helps improve model performance and learning efficiency. And the next is the SVM models, the classification and the regression. So I apply support vector machines. The SVM classifiers used to separate classes using decision boundaries, and the SVM regressor predicts the continuous values. I also tune the parameters like C controls the margin and the gamma controls the influence of data points. So this improves the accuracy of the model and the performance of the model. So this implementation compares neural networks and SVM models for both classification and regression and shows how tuning improves the performance of the model. So this is experiment number 5.